Hello everyone, welcome to RN tutorials. Now we are going to discuss about viscosity of a fluid, which is one of the properties of a fluid. So first I want to give the definition for the viscosity. So it is a basic property of the fluid which offers resistance to the flow of the fluid as one layer of the fluid applies resistance to the other adjacent layer. So that means here if we assume the flow of the fluid in number of layers, the each and every layer will be applying certain resistance force to the other adjacent layer to its motion. Okay, so that resistive force is called as your viscous property. The resistive force, the applicability of resistive force by one layer to another layer for the fluid motion is called as viscous property. Okay, so now I want to consider a fluid which is flowing on a base, so which is fixed one. So again on base there is a plate is there which is moving with a velocity. So in between these two plates I want to assume one flow of the fluid or liquid or any other oil is taking place. So whenever this plate is moving with a velocity v, so this top layer also will be moving with the same velocity v, and when you are going downward the velocity will be decreasing due to the viscous property of the fluid. So why? Because means the viscous property itself causing the resistive force. So whenever this layer is moving, so this layer also will be moving in the same direction only, but this will be applying certain resistance to the flow of this upper adjacent layer. Similarly, next layer will be also will be applying certain resistive force to the moment of the above layer. Similarly, each and every layer will each and every layer applies certain resistive force to its adjacent layer, which is due to the friction also we can say that in between the fluid particles. So that is due to the viscous property of the fluid only. So because of this viscous property, due to this resistance is taking place, the velocity will be reducing when you are going downwards. Why? Because when you are going downwards, number of molecules of the number of fluid particles are increasing. So due to that viscous property also increases, so that the resistive force also increases, then the velocity decreases. Okay, so when we try to draw a velocity gradient or velocity curve for the flow of the fluid when it is flowing in between the two plates or any base, so here we'll be getting the curve like this. Why? Because at the top layer of the fluid will be moving with a velocity equal to the velocity of the plate, which is v. So when you are going downwards, due to the viscous property, the resistive force is uh, going to be increasing. So due to that, the velocity decreases. So finally at the bottom of the plate, so the velocity becomes zero. Why? Because means here certain resistive force, here the resistive force is becoming maximum, and here the plate also can apply certain amount of the force to the flow of the liquid. Okay now, so due to this maximum resistance is taking place at the bottom of the plate, which is due to the viscous property, and one is due to the friction of the plate, the velocity will be becoming zero. Okay now, so I want to assume two layers. Okay now, next I want to derive the equation for the viscosity. For that I want to assume two layers which are at a distance of dy, and one layer is moving with a velocity u and another layer is moving with a velocity u plus du. Why? Because when you are going upward the velocity is increasing. So if it is u means the small change in velocity I am assuming du. So whatever the layer above it, the velocity will be, or velocity is u plus du. Okay now, so these are the two layers I've assumed. Okay, so and this velocity variation is taking place due to the uh, viscous property only, which is due to the resistive force. Okay, so next the velocity gradient or the slope can be written as, so I want to write the velocity gradient, which we can call it as a slope of this curve also, whatever the curve we have obtained. So how can we write? Means here how the velocity variation is taking place according to the distance between the two layers, or when you are going downward. So that means with respect to the displacement or distance in the downward direction or distance between the two layers, the velocity variation is taking place. So the gradient can be written as change of velocity with respect to the displacement or distance, because the variation is taking place with respect to the distance or displacement. Okay, now when you are going downward, that is distance we can consider. Okay, so here that can be written as rate of change with respect to the distance between the two layers, which is the velocity gradient or slope of the velocity. Okay, velocity curve. So next I want to write shear stress. So here I'm saying that shear stress takes place due to the viscous property of the fluid. So again I'm saying the shear stress is taking place. Why means here? So whenever you are saying that due to the viscous property, certain resistive forces are acting in between the two layers means how they are acting tangentially to each other only. Okay now. So when they are moving in a parallel in the form of layers means the resistance will be applied to the another layer tangential to its uh, direction only. Okay now, so tangential force we consider it as a shear force. Okay, so shear force ultimately causes the shear stress. So that's why due to the viscous property in between the layers of the fluid, when the motion of the fluid is taking place, it causes shear stress. Okay, so next, this shear stress, from the Newton's law of viscosity we can say that this shear stress is proportional to the velocity gradient or rate of shear stress. Okay, or rate of shear deformation. Here the velocity gradient will be saying that we used to say that rate of shear deformation. Okay na. So why rate of shear deformation means here the deformation causing the rate of change of velocity with respect to the displacement here. Okay, so that's why, so when you are coming downwards the velocity is decreasing. Okay, the rate of change of velocity is taking place due to the resistive force means due to the viscosity only. Okay, that means there is a certain relation between the shear stress and the velocity variation also with respect to the distance. Okay, so the Newton's law of viscosity states that whatever the shear stress is taking place is proportional to the velocity gradient. Okay, so now try to apply that. Tau is proportional to du by dy. So ultimately by using one constant of proportionality, mu, I have written the equation as du by dy, which is making the relation in between shear stress and velocity gradient. These two are taking place due to the viscous property only. So uh, this coefficient of this coefficient is called as viscosity only. Okay na? So the coefficient, by using certain coefficient, I have written the formula this one. So this coefficient itself is the viscosity, which is making the relation between the shear stress and the velocity gradient, which are taking place due to the ultimately viscosity only. Okay, now mu, here mu is called constant of proportionality. Okay, or coefficient of viscosity or dynamic viscosity or viscosity we can call it as. Okay, mu is called as constant of proportionality, coefficient of viscosity and dynamic viscosity or viscosity. Okay, so now mu can be written as tau by du by dy. This is the final equation for the dynamic viscosity or simply viscosity, which is the property of a fluid. Okay, so now I want to write the units for this equation. Okay now, how to write the units? Here by analyzing the whatever the terms are taking place in the formula we can write. So what is the unit, what are the units for tau, that is shear stress? Units are Newton per meter square. Similarly by, what is the units, what is the, sorry, what are the units for velocity meter per second? Similarly by, what is the unit for displacement or distance? Meter. Okay, so now that can be equal to Newton by meter square. This meter square we can take it to the denominator. Okay, Newton by meter into meter square, and this seconds, again this second goes to the denominator, so meter into second we will be getting. So next we go for next slide. So same whatever I have written in the previous slide, the same I have written. So in this here, when you keenly observe, this meter gets cancels. Okay, so next equation remaining will be this seconds goes to the numerator. Okay now, and Newton second per meter square, which is the, which are the units for the dynamic viscosity, Newton second per meter square. Okay, this is the these are the units for the viscosity in SI system. Then whatever the units in MKS system, in MKS kg force second per meter square. Similarly in CGS, dyne second per centimeter square. Okay, so that 1 dyne second per centimeter square is called as 1 poise. Okay, in the problems we have to know how to convert, if the viscosity is given in poise, how to convert it into Newton second per meter square. So there is certain relation is there. 1 poise is equal to 1 by 10 Newton second per meter square. That is the relation between the CGS system and MKS system. So 1 dyne second per centimeter square is called as 1 poise. So 1 poise is equal to 1 by 10th of the 1 Newton second per meter square. By using this relationship, if the value is given in poise in the problem, we can convert it into Newton second per meter square by multiplying with 1 by 10. Okay, so this is about the viscosity, which is one of the basic properties of the fluid. Okay, so I hope you understand this explanation. If you still have any doubts, please feel free to give a comment to my video. If you really like my video, please give a thumbs up, and don't forget to subscribe to my channel. Thank you all. Thank you so much.